This video is about the confusion matrix and psychometrics. What is psychometrics? In machine learning, data science, statistics, math, and logic most broadly, everything is based on assumptions, many of which are based on lots of study and evidence going back decades, centuries, and millennia, thousands of years. Math and science are great areas of human collective learning. If there's enough evidence and no one has been able to show different, assumptions are often called rules, theorems, laws, and so forth. But they're almost always incomplete and might not be true, at least in some ways. Good to keep in mind. A basic assumption underlying the confusion matrix is that what we know is actual or true, the gold standard, the reality, is actually knowable. We need this to calculate and understand how well a prediction model performs. To improve our ability to determine what is happening with psychological problems, scientists have developed psychometrics or measurement science as a way to increase our capabilities to observe and measure things we are not able to directly observe. Some things are easy to see and measure, such as which basketball team won the game. What is harder to measure is what factors predict who wins. Since there are many factors that can be combined in exponentially many ways, building an accurate model for calculating win probability can be a lot of work with numbers and what the numbers mean, measurement science. Machine learning can make this more doable by automating that work. The more work can be automated, the more doable prediction can become. Especially with suicidality and the psychological, biological, and sociological risk factors, such as psychological problems interconnected with emotion and brain function, we don't have a direct way to completely observe what is actual or true. Likewise, with sociological aspects, such as each person's individual social network, degree of isolation, observing and measuring, that can be a challenge. In this table, the columns are what is the reality according to a gold standard, such as a lab test or could be expert opinion on something. And the rows represent the results from a screening test. The four main concepts: sensitivity, specificity, positive predictive value, and negative predictive value express an important difference in orientation or perspective. If we think about getting a test, a positive result, we do a test and it says positive, then the question is, how well is that test performing to predict actual reality? That's the positive predictive value. In other words, if the test says positive, what proportion of the test positives are actually false positives? Likewise, if the test says negative, we want to know the negative predictive value. How many of the people who are tested as negative actually are negative versus actually not negative? From the other perspective, according to the reality, whether someone actually has a condition or not, if someone has a condition, then the question is, how well does the test perform to detect that? That's the sensitivity. So that's the ratio of true positives over true positives plus false negatives, the column. Likewise, if the person does not have the condition, we want to know how specific the test is, which is the ratio of false positives as the numerator over the sum of false positives and false negatives. In measurement science, two core concepts and terms, or in psychometrics or measurement science, are manifest variables, observations at the surface, like the tips of icebergs, and latent variables, which we only can infer using statistics, machine learning, philosophy. These are underneath the surface, like 90% of icebergs. Another core term is construct, another word for latent variable. We use the word construct because we are constructing something to describe, study, and better understand what we are trying to observe. Depressive disorder is a construct, as is social anxiety disorder, like any psychiatric diagnosis and any defined mental and behavioral health problem. In the confusion matrix, constructs are generally a category or class and can be present or absent, predicted or actual, yes or no. In suicidality, key categories are suffering, suicide ideation, suicide plan, suicide attempt. Machine learning can be applied to study how to predict the formation and presence of each of these mental states, the probability of transition from one to another, such as moving from non-suicidal suffering to developing suicide ideation. Understanding and predicting the chances of someone making a suicide attempt is especially important. The earlier we can apply psychometrics to collect meaningful data and machine learning to more fully use the data to detect suffering, suicide ideation, and suicide plan formation, the earlier we can intervene to reduce the suffering, lower or eliminate suicide ideation, prevent suicide attempts, and overall help find better ways to manage suicidality. In the diagram, three main areas of underlying or latent variables are sociological, biological, and psychological. Manifest variables can be things like gender, age, income level, having an injury, and so forth. The way that measurement science conceptualizes how the manifest variables relate to latent variables is that when we measure the manifest variables, we can infer the presence of an underlying or latent variable, such as suicide ideation or suicide plan. But the way the manifest variables are created is that they are created by underlying unobserved processes, again, suicide ideation, suicide plan formation, suicide attempt, that generates things that we can observe above the surface, or in this case, below the red line. Science is a way for us to change the boundary between latent, unobserved states and processes and manifest variables that we can observe. If we can move the boundary between unobserved and observed, move the surface towards the underlying factors, then we can observe more things, such as suicide attempts. Overall, these are abstract concepts about general class of latent variables. Latent variables, again, represent underlying structures and processes. We infer their presence based upon surface observations. We can actually test for whether or not latent variables seem to be present. This can be by forming hypotheses, a way to pose and answer questions, and latent variables can become directly observable with advances in science and technology. An example of informal psychometrics and the reality matrix is what we know and don't know about ourselves, what others know and don't know about us. The name for this matrix is Johari window. In the Johari window, the open area is things that we know about ourselves that others know. Blind spots are what we don't know about ourselves, but others know about us. Hidden area is what we know, but no one else knows. And unknown areas are areas about ourselves that we don't know, nor do others know. Unknown areas are important areas to attend to uncover what's going on. Unknown areas are major, latent, unobserved variables. Thank you.